Hello, my name is Moin Raman. I'm the principal scientist at High Velocity Human Factor Sciences, HVHF Sciences. I specialize in the human factors and user-centered design of critical communication and computing technologies. Today, I'll be talking about the use of big data. The title of my presentation or focus is going to be the critical data in big data and designed for human-centered situation awareness. So the topics that I'm going to cover today are: one, define what is situation awareness; two, how do we size big data with the help of data analytics to provide or deliver situation awareness; three, close my presentation with my summary thoughts. So what is situational awareness? Situational awareness in its simplest form is just knowing what is going on around us, but it is much deeper than that, because situation awareness just doesn't happen or manifest itself out of thin air. The first step is to perceive critical information that is relevant to the mission on hand, as well as the what are the big goals that need to be accomplished. So when driving a car or landing a plane or putting out a fire in a building, there are critical pieces of information that need to be perceived first, which are relevant in terms of keeping us safe or accomplishing our goal. Second, we need to comprehend or understand those critical pieces of information in terms of their relevancy, timeliness, and how do we utilize them to make decisions. And thirdly, to project them in terms of what the immediate future is likely to be or how the event is going to unfold. So situation awareness can be understood with the aid of this diagram here. Actually, this is a model of situation awareness that has been developed in the human factors sciences. There are three steps to it: perception, perceiving the critical elements. That is, just perceiving alone just results in level one situation awareness. Comprehending that critical pieces of information or understanding that results in level two, and then projecting it and forecasting what the immediate future is going to be results in level three. But there is more to just perceiving comprehension and projecting the uh, critical information in the mission space out there, because there are individual factors in play. If you look at the bottom rectangle here, uh, there are goals in some people's heads, the human operators in the mission system, firefighters, drivers, or whoever they may be. There could be preconceptions, knowledge, skills, abilities, training. So those individual factors come to the fore in terms of how situational awareness is perceived and how it is processed. And then on the top, you see the task and environmental factors. Those are the amount of workload, amount of multitasking that is going on, the time stress, and the imminent threat, and that causes emotional arousal in terms of how people see and what they see and how they prioritize. And then the complexity of the system design, and the complexity. So both the individual factors, the human factors, and the task and environmental factors both have an impact on how situational awareness is acquired. And once the situational awareness is acquired, the next steps involve making the decision so that the goal on hand is accomplished, or at least there are subtasks or sub goals towards the larger goal that need to be accomplished, like, say, rescuing someone or putting out a fire, or shoring up a collapsed structure, and then performing the action. So there are this many steps literally going on under the hood in terms of knowing what's going on around us in a critical infrastructure domain. The same thing can be said for utilities in a command and control center, as well as in transportation, especially in the realm of intelligent transportation technologies and connected cars and all of that. Uh, because as much as the intelligence and technology is, there is the system, the machine too needs to be smart enough to know what's going on, and oftentimes both the humans and machines work together to acquire situation awareness and to command and control the elements that are at work or in play in a particular domain. And there are different types of situation awareness. One, just what an individual might acquire, say sitting in a driver's seat in a car, or a first responder delivering advanced life support to someone who is badly injured in an accident, sizing up what the situation is and how to triage. And then there is shared situation awareness. If both the individual at the tip of the task force, at the tip of the mission, say on the road where the accident has occurred, is doing something, and also the emergency physician knowing in the nearest trauma center, knowing what's going on there. If both have an idea of what's being done, then it is shared situation awareness, because it's more than one person. And then there is distributed situation awareness, say especially in utility grids and in large scale natural disasters. Different teams are working on different things. They may not necessarily know what each other is doing, but they have kind of parsed or broken up the systems into smaller components. So the search and rescue team would be focusing on search, knowing where to go. The paramedics in terms of delivering the first aid or the medical aid, and then the logistics team making sure that everybody is connected on the radio, everybody is getting the necessary information. You know, that you have the COML, the COMT, the communication leader, the communication technician doing their job. So that is distributed situation awareness. Each one of these teams or specialists is looking into their own subdomains. And then there is joint situation awareness, where humans and machines cooperate or work together in terms of getting the situation awareness of what's going on. Say it could be in an aviation system, it could be in first response. So that's something very interesting, especially when you think of things such as deep learning and cloud robotics. So the ultimate goal is, as you see here in the picture on the right, is to take these nuggets of data points and connecting the dots literally to make sense of what's going on. That's what results in situation awareness, and that needs to be relevant. So how does big data come into play when it with regards to situation awareness? It can be very useful, and if designed improperly, it can also be very harmful, as I'm going to discuss. So here's big data in action. The best known example of big data in use in popular culture is how Billy Beane of the Oakland A's put data into use with regards to getting the best ever performance with the smallest possible budget, because the Oakland A's didn't have the kind of money what big teams like New York Yankees had. They had to work on 1/3 of the budget, yet produce very good results, and for which Billy Beane, a very prescient scout who was a former player himself, chose to rely on data analytics. And he concluded, this is a quote from the book and the movie, your goal should not be to buy players, your goal should be to buy wins, and in order to buy wins, you need to buy runs. If you were to look at the very traditional model of scouting and recruiting players, it was more to do with the terms used in the baseball vernacular, the hose, the wheels, and the body, meaning a very strong shoulder and arm. The hose, wheels, how fast someone could run, and how handsome and how athletic one looked. Probably they do have a role, but eventually the runs scored are correlated to the amount of time spent on base, the percentage of time spent on base. It's not even to do with the average team scores. To a certain extent, that correlation is somewhat weaker. So some of these very interesting nuggets or patterns of data were crucial in enabling Billy Beane get his performance, or make the Oakland A's one of the very good performing teams in the league, just with $40 million, as compared to New York Yankees payroll, which was about $120 million. And this is in 2002, not today. So that's why those numbers are small. So strategic thinking needs to be combined with big data, and that's why an expert human factors interpretation is needed to getting the solution right. So there are these big data characteristics that are well known. There's a lot of volume, velocity, that a lot of data comes in because of various type of sensors in a particular domain. And then there is a variety. There could be infrared sensors, body-worn cameras, and then there is veracity. There's always some uncertainty. The data feed might not be clear. There might be a lot of electronic or radio noise. So there are quite a few challenges in terms of handling big data. And there are also problems too, as I was mentioning. Big data left to itself, were to use a machine algorithm, it could see patterns which just don't make any sense at all, and one should not uh, proceed because big data says that there is a relationship. And here I'll give you an amusing example. So if you were to look at the data between 2006 to 2011, it shows that there was a positive correlation between the United States, the murder rate in the United States, as well as the market share of the browser software, Internet Explorer. So with the sales of Internet Explorer going up, the murder rate too went up. So it makes one wonder what is the correlation here. Probably there is none at all. But data is data. Just raw data can lead to such spurious conclusions. And when we look at big data in critical infrastructure domains, it can be used, it can be analyzed in three possible ways: for predictive analytics, prescriptive analytics to prescribe what needs to be done, and also real-time analytics. And I'm going to give you two quick examples here. So if you look at a typical public safety domain, command and control structure all the way up to the tip of the strike force or the task force, the one here in the red, which is shown as mission critical. There are three layers to support the, actually two layers above the mission critical to support it: the mission essential information that needs to be present, and also mission functional. So the predictive analytics is used in a mission critical domain or public safety domain more in terms of trying to predict or forecast where the crime is going to occur, or where fires are going to break out based on past history, wind patterns, activity, and so on and so forth. So predictive analytics is very useful at the strategic level for allocating assets and coming up with a work plan, so to speak. Not so much in the mission critical level where it needs to be very immediate and actionable data. So predictive analytics is at the mission functional level. That's where the risk engines and such are utilized to process big data. And the prescriptive analytics is used more at the tactical level, at the mission critical level. And here's a typical example as to how data can be harnessed to inform the police officer when it comes to traffic stop as to whether the vehicle is registered or not. There's a license plate reader who is likely to be in the vehicle, and what can one expect. And for this to happen, the interaction between technology as well as the human being inside the truck needs to be data driven, fact based, and it needs to be, the veracity needs to be there, and it needs to be intelligence led, in the sense it should enable the police officer make the right decisions, and sometimes even the machine, based on the officer's past history, mistakes, experience, skills, can come up with recommendations. And all this is done while he's sitting inside the car, even before he gets out of the vehicle to engage with the citizen who was stopped. And to make a long story short, for all the data that is produced, it needs to be sort of sorted out, and just the relevant nuggets of information need to be presented. So what I mean by that is more data does not necessarily mean more information. There is the critical information needs to be siphoned out and presented based on context and what the goals are in that particular moment. And the best way to look at it, if you were to consider this big data, raw data, when data is put into raw data is put into context, we need to, meaning it needs to be filtered out to produce the data that is relevant to that particular context. And when it is interpreted by the human being who is going to utilize this data, then it turns into information. And then this information needs to really be linked to the situation on hand in terms of how it could be applied or operationalized. Only then it turns into knowledge. So there are these three steps that need to occur from this raw big data that is out there in the cloud or in any number of databases and servers that are kind of pumping out to our devices and machines. So that much of cleaning needs to happen before the human being can process it. Here is an example of real-time analytics. This is a very tragic event. In 2003, there was a wildfire in Yarnell Hill, and 19 Hotshots were killed. And reason being, there was, as you see here, the geospatial images. There was a sudden change in wind pattern, and because of that, the fire changed direction and it started coming towards the firefighters. And here, big data, if properly had been utilized and designed, the technology is still evolving in terms of the fuel source, trying to understand what the fuel source is, what is the intensity of the heat, the oxygen level, the wind patterns, the past history. It could have preempted this tragic incident by informing the lookout as well as the central command and control in terms of where the firefighters or the hotshots should not be going, or by what time they should be withdrawing. So that there could have been some help in terms of utilizing big data in real time. So to conclude my presentation today, here are my closing remarks. First, the big data has to be sized, and for which we need human subject matter experts to take the relevant data, what is presented by the machine, and to link it to the situation on hand, just like what I said about Billy Bean and in Moneyball. So data left to itself won't offer us situation awareness. It needs to be designed. And then there are three types of analytics that need to be run based on whether it's strategic or operational or tactical, predictive, prescriptive, and real time. And then they need to be integrated in terms of how the human operators operate in a particular domain, be it in utilities, transportation, or public safety. And there are different types of situation awareness, as in a recall, individual situation awareness, shared situation awareness, distributed situation awareness, and joint situation awareness. So there are different strategies to design those things. And lastly, the data that has to be turned into knowledge, and that brings us to usability and utility of big data analytics. So there are three steps to convert the raw big data into data that is filtered and relevant to the situation on hand. Then it is put into context, it turns into information, and when it is understood, it becomes knowledge, which is really what we want. And here is I'm using a cartoon. What I'm trying to say here is just increasing technology with sensors and a lot of data being thrown out there in the cloud does not necessarily increase anyone's situation awareness, and it can actually cause more harm by distracting people or making them too focused into something that is irrelevant. As you see here, as someone is kind of walking the street, not being unaware that a car is coming here. So with this, I conclude my presentation. Thank you very much for your time, and the floor is open for questions.